For over 35 years, Robertson Fuel Systems has been the source and acknowledged world leader of crash-worthy fuel systems for rotary and fixed-wing aircraft. Taking this extensive knowledge and experience and combining it with leading-edge innovation has enabled Robertson to design and develop survivable fuel solutions for ground vehicle systems as well. Robertson proudly supports Army aviation by extending the reach of freedom and the Army's ground combat vehicles by driving enhanced survivability. First, let's take a look back and see how and why Robertson Fuel Systems came to be. Prior to the development of crash-worthy fuel systems, occupants who survived the impact of an aviation crash frequently perished in the fires that would follow. Crash studies and accident investigations showed that fire was the single most common cause of crash fatalities. Understanding this, a team of researchers in the 1960s, led by Dr. S. Harry Robertson, determined the sources of these fires and developed solutions to eliminate them. Their work led to the development of the crash-worthy fuel systems that are used in military aircraft today. Consequently, fuel system crashworthiness is now an accepted requirement in nearly all military aircraft. As a result, countless lives have been saved, and fatalities due to post-crash fires in aircraft using Robertson systems are now virtually non-existent. Furthermore, extended range capability has been designed into all of Robertson's auxiliary aircraft systems, providing mission commanders with the added flexibility and range to fly farther and fight longer. Inherent in all Robertson aircraft fuel systems are the following features: capable of being installed or removed in just minutes using few or no tools in order to maximize the mission commander's flexibility. Integrated with all other aircraft systems to the maximum extent possible, only adding and never subtracting any capabilities. Designed with a minimum footprint to avoid interfering with aircraft operations. As modular as possible so that they may be used singly or in combination with other systems. Robust and reliable in hostile conditions. And above all, they must be crashworthy and ballistically self-sealing to protect the safety of the Army aviation crews and their passengers. To ensure all new Robertson aircraft systems meet these exacting design requirements, they are put through the same rigorous tests. The crashworthy bladder of every new system must pass a 65-foot drop test without showing evidence of leakage. The ballistically self-sealing bladder of every new system must undergo gunfire tests and stop or slow the leakage of fuel within a specified period of time. Each new system must endure a rigorous slosh and vibration test that simulates operation in the aircraft. Upon completion of the test, the system must continue to function normally. And in some cases, a full-scale crash test is performed with the system installed in the test aircraft. There are two possible missions you'll be able to accomplish with the Extended Range Fuel System 2, or ERFS-2 as it's more commonly called. Mission 1 is to extend the range and endurance of your CH-47D or F model Chinook up to nearly triple that of the helicopter if it were not equipped with the ERFS-2 system. And Mission 2 is to transport and deliver up to 2,400 gallons of fuel for tactical forward area refueling for aircraft or other combat weapon systems. In addition, these two systems may be combined. To provide this mission flexibility, the modular design of the ERFS-2 allows the mission commander to select the proper combination of ERFS-2 components that best suits the specific mission requirements. These ERFS-2 components, tanks, hoses, harnesses, pumps, and control modules, are all carried internally. Power to operate the ERFS-2 tanks is provided by the helicopter electrical system from utility receptacles located within the cargo compartment. All controls and indicators needed to operate the ERFS-2 are contained in the control modules associated with the ERFS-2. With the ERFS-2 on board, there's no restriction of flight operations as a wide 25-inch aisle permits easy access to the cargo compartment for normal crew duties or emergency exit. The backbone of the ERFS-2 system is the ERFS-2 tank. The ERFS-2 tank is carried in the cargo compartment of the helicopter and is secured to the floor utilizing a specialized restraint system. The tank is roughly a 5-foot cube and can carry approximately 800 gallons of fuel. Empty, the tank with restraint system weighs approximately 700 pounds. From 1 to 3 tanks can be installed in the Chinook, allowing up to 2,400 gallons of fuel for range extension and/or forward area refueling. The IRFS 2 tanks are designed to be both crash-worthy and ballistically tolerant. Control of the IRFS 2 tanks is through the use of a fuel control panel that is mounted on the forward IRFS 2 tank. The power to operate the IRFS 2 tanks is provided by helicopter electrical system. An electrical harness connects to a utility receptacle, both AC and DC, located on the helicopter's left-hand side. Power is distributed from the fuel control panel to the tanks via individual electrical harnesses. The IRFS 2 connects with the Chinook's single-point pressure refueling system to allow simultaneous servicing of both the Chinook and IRFS 2 tanks, or, if desired, the IRFS 2 tanks may be serviced by gravity refueling through the filler opening. This separate module is called the FARE Kit, which stands for Forward Area Refueling Equipment. It contains all the components needed to simultaneously deliver fuel to 2 aircraft or other combat weapon systems at an approximate distance of 200 feet from the Chinook. The FARE Kit is also secured to the cargo compartment floor utilizing its own specialized restraint system. Once at the Forward Arming and Refueling Point, or FARP, the FARE components, including pump, hoses, filters, and nozzles, may be configured to deliver fuel using a pump rated at 120 gallons per minute. Like the IRFS 2 tanks, the FARE pump receives its power from the helicopter's electrical system using a harness that connects to the AC and DC utility receptacles on the right side of the aircraft. The FARE pump mounts identically to the fuel control panel, except it mounts on the rear IRFS 2 tank. Part of the FARE pump is a control panel to which is attached a remote control harness. This remote switch allows control of the FARE pump while outside the Chinook and in view of the receiving aircraft or combat weapons systems. If your mission calls for auxiliary fuel, the IRFS 2 will give you the capability you need. An alternative to the IRFS 2 is Robertson's Reduced Size Extended Range Fuel System, or RSURFS. The RSURFS incorporates a 520-gallon tank that inherits all of the features and capabilities of the larger IRFS 2 tank, yet is 20 inches narrower, allowing additional cargo space and increased troop seating. A single RSURFS installation provides 58 cubic feet of additional cargo volume when compared with the 800-gallon IRFS 2 tank. Both the IRFS 2 and RSURFS permit component interchangeability, which simplifies installation and functionality. The typical RSURFS installation is singular, but like the IRFS 2 tanks, up to 3 RSURFS or any combination of RSURFS and IRFS 2 tanks may be installed along with the FARE Kit. Any RSURFS configuration allows a much wider aisle, which facilitates movement and placement of additional troops and cargo. The CH-47 RSURFS received an airworthiness release for special operations and the U.S. Army National Guard in 2012.